Okay, hi everyone. I think we can get started. We have our guest of honor here. Thank you so much for joining us today. Can you all hear me, right? Yeah? Thank you so much for joining these really exciting iWISH talks, inspiring women in science and healthcare series of talks. My name is Francesca, and I am delighted to have to co-host this event together with Zara.
Hi, everyone. We are overjoyed today to be in our first in-person event with Dr. Bertozzi.
And yes, so we are both really honored to have Dr. Bertozzi here in person, and we will engage in a conversation with her about her career journey and her vision of the future. And I really can say that this room full of people, and we have an overflow room in the same floor full of people that have been waiting here for more than 1 hour. And I think this is really the best way to say that we really looked forward to have you here in our events. So I think we can all welcome Dr. Bertozzi with a good round of applause.
Thanks.
Thank you so much. So, and before we dive into our Q&A session, I would like to really briefly introduce the iWISH talks to all of you guys. There are so many new people in our events. So this is an early career initiative built by early careers with the desire of having a platform that really connects, inspiring role models with the next generation of leaders, and to learn from them, from their journey, how they get there, how they reach the successful positions while navigating challenges. And again, this is a platform for all of us, and we believe this is open to public and for all genders. And this is our wonderful team of postdocs, faculty, and staff who really puts a lot of efforts to organize every single detail of these events to make this a unique experience for all of us. And we are obviously supported by great mentors that guide us along the way, step by step, and we are very grateful for that. And so today's event is kind of divided in two main sessions. Zara and I will discuss about a couple of main topics with Dr. Bertozzi, and then we will open the Q&A session for all the audience online and in person. So please keep your question ready, because it will be your moment. And Dr. Bertozzi is a professor in chemistry, and she's the Baker Family Director of Stanford ChEM-H. She has been awarded the Nobel Prize in 2022 for her discovery in bioorthogonal chemistry, which is the study of chemical reactions within living organisms without impacting their natural biological processes. And one of the aspects that really fascinates us of your leadership is the fact that it's your mentorship. So you're very available to your team. And one of the things that catched our attention in your talks is that you put a lot of emphasis on diversity, how important is diversity in your team. And so discussing about mentorship, we know that mentorship as well as advocacy and sponsorships are three important characteristics that really can impact the career of us as researchers. So we are wondering, how do you identify individuals that can cover these three different aspects, and how do you really seek for support from them?
Great. Well, so first of all, Francesca, thank you so much for hosting this event and for inviting me. The good news is, since I'm here at Stanford anyways, people should feel free to meet me outside of this room, right? Especially if they couldn't fit in the room. But I feel like, can you see me in the back there? Maybe I should stand. Would that be better?
Yeah.
Okay. So I think, if I understand the question, that you're asking, how does a person find a mentor, or how do you know what a good mentor looks like, or something like that? Maybe, yeah. It's a tough one. I mean, I had my own. Oh, look at that. This is very professional. Okay, is that still all right? Okay. So, you know, I've experienced good mentorship and not so good mentorship in my own life and career, starting when I was a student. So, you know, I think one thing I've learned over the years is that a good mentor is one who listens to you and sees you as an individual and not just as a sort of nameless, faceless cog in the bigger wheel of whatever they're trying to accomplish, who is flexible, you know, and can kind of understand what your needs are. And no mentor is going to meet all of your needs. That's impossible, nor should it really be expected. But I think just having a mentor who fundamentally is kind of aligned with the same true north on their compass as you have on your compass. And so, you know, for example, one thing I try to remind myself is that when I have trainees that are looking for mentorship, often they're coming to me with an idea. And then the question is, you know, what can I do to support them? And I try to remind myself that if they are excited about doing something or pursuing something, if they're excited about it, then by definition, I'm excited about it too. So I think maybe that those are some very high level hallmarks of the mentors in my world that I think have been most helpful to me. Having said that, when I was a PhD student, I probably learned more about what mentorship ought not to look like than what mentorship should look like. I also learned that not all advice is good advice, even when it's coming from people who should know better, you know. And I got a lot of advice from my senior faculty, you know, mentors when I was a PhD student that I think was actually not good advice for me. It might have been good advice for other people, but it just for me, it didn't really work for me. And in hindsight, I think the problem was that there was a mismatch between what I wanted and what was important to me and what my senior faculty mentors thought should be important to a person at my stage, right? Those were two things that were out of alignment. And I think when I did make the decision to sort of go against the advice and pursue what I thought was right for me, it always worked out well. So maybe my advice, what I learned, I think, is don't take advice. Maybe that's my advice, is don't take anybody else's advice, you know, unless you really feel that it resonates with what you already want. Advice, in a way, should be reinforcing of what your instinct is and not something that causes you to relinquish a dream or a goal and pursue something that really doesn't fit you very well.
Well, thank you so much for this insightful answer. I think we all can take in that we should, yes, maybe seek for advice, but really internalize and see what we really want to
criticism.
do. Yeah. So as we are, most of our in the room, that we are all researchers, and we know that the research is giving us a lot of joy. Otherwise, we wouldn't stay long hours in the lab. But we know that being a researcher comes with a deep responsibility. And as it's not just advancing knowledge for us and for other researchers, but also understanding how the world, you know, goes around. So we are wondering how the gravity of being a researcher and a leader in this field change over your career.
Yeah, so I mean, there's things that have changed, certainly, because my whole life has changed, you know, but there's a lot of things that really haven't changed at all. You know, I'm a chemical biologist, and as a PhD student, I was very much focused on organic chemistry and organic synthesis. That's where my passion was at that time. But I became more and more interested in the biological sciences and biomedicine. And so my research interests as a postdoctoral fellow kind of shifted more towards immunology. And then when I was a young professor with starting out my new lab, it was really focused on developing chemistry-based technologies to help study biological problems, but basic science. And so there was a phase, you know, in my early independent career, for the first 10 years or so, we were very focused on basic science and making tools to help facilitate basic science. But then, you know, kind of into my late 30s and early 40s, I started, you know, we made discoveries in the basic science that had implications for translational science. So, you know, we had discovered some biological pathways that were relevant for drug development and specifically for cancer immune therapy. And the concept of cancer immune therapy was kind of a new thing. You know, this kind of takes us back to the single digit 2000s, you know. And by the time 2012, 13 or so rolled around, I started to feel frustrated that I didn't, first of all, know more about medicine and translational science, but also that I didn't have an ecosystem to pursue those kinds of interests, because I was at a different university, which didn't have a medical center. This was UC Berkeley, which is a great institution for basic science, but, there's no medicine right there at the Berkeley campus. So, you can reach out and collaborate with folks around the Bay, but it's not the same as like what I just did, which was walk from the ChEM-H building to this building. And now I'm on the medical school campus, right? So then I moved here, right? And a big motivation was to learn more from the physician scientists, to be in a place where there's patients and clinical trials. And I thought it would really benefit what was sort of emerging as an interest in drug development. Right. So that's kind of the arc of my career, starting very basic science, very chemistry focused, shifting more towards biological sciences, then biomedical science, then translational science. So, but at the same time, a lot of things really haven't changed about the way that I get excited about science. I every day I get up and can't wait to sort of get on my, journal feeds and see what papers have come out that are cool and new and exciting that I could share with my group. When I see something cool, either a talk or if I travel and meet someone really interesting who's doing something that I learned from, I'm excited to come back and I want to talk to my students about it and share what I learned. And so that's, in that sense, I don't really feel that different than I did when I was in grad school.
Well, that's really inspiring, and I really liked that you touched base on the drug discovery, right, as well as basic science innovation. And we are fascinated by the fact that you have this ability to bring these two together. So you're a co-founder of multiple biotech companies and advisor for multiple others, as well as you have your own lab, right? But these two, the academia as well as the company, although they kind of bridge together, but they have different goals, or the way in which they reach the goals is slightly different. So for many of us, we would like also to learn kind of entrepreneurship skills. So how did you learn and how did you get experience as an entrepreneur? And as well, how can you make these two fields going along with each other together?
Okay. Well, so I'm still very much learning, how to be a successful entrepreneur and scientist at the same time. I mean, there's always failures and learning along the way. So Stanford is a really great place for this. And that was another element of this university that I actually didn't fully appreciate until I moved here. And I've been in the Bay Area since grad school. That was in late 1980s. I moved to California, did my Ph.D. at Berkeley, then postdoc at UCSF, then joined the faculty at Berkeley, and then eventually moved here, right? So I've just always been around the Bay Area. And you might have thought that being at Berkeley and UCSF, that Stanford, Berkeley, UCSF, that wouldn't be all that different. We're all in the same ecosystem, but Stanford is really different, actually, than Berkeley, certainly. And just to put some numbers on it, I was on the Berkeley faculty for 20 years. And I started one company out of Berkeley. And then I moved here 9 years ago. And since moving here, I've started 13 additional companies in 9 years. And it's not like I came to Stanford thinking, oh, now I'll just crank out a company every 6 months or something. That wasn't a goal. I didn't actually realize how much easier it is to start companies out of Stanford. It's much easier than Berkeley. Probably UCSF is somewhere in between, is what I'm guessing. But and it's easier for a number of reasons. First of all, Stanford has a history of this, and we're located right in the heart of an environment with a lot of venture capital groups that focus on healthcare, and they hang around here. They just kind of showed up in my office. They started showing up in my lectures. Events like this might even have a few of them lurking in the room for all I know. That's okay. You don't have to self-identify, but I've just noticed they just pop out of the woodwork. Like, yesterday we finished the second day of a chemical biology Bay Area conference, which was joint between Berkeley, Stanford, and UCSF, and we held it here, right? So I had this event at the Arriaga Alumni Center for the last 2 days. And sure enough, I see a bunch of people with their name tags and it's a VC affiliation, right? So they registered and came and paid their $25. Should have charged them more in hindsight, but so they're just around, right? And so I found I had a lot of inbound interest and cold calls they would see something we published or see a talk that I gave and say, hey, have you ever thought of starting a company around that? So there was that. The other thing is the students that I have and the postdocs that I have at Stanford, they seem inherently more interested in pursuing entrepreneurship as a career path after their training. So I've had several Stanford PhD students who, right after their PhD, literally together with me and maybe a few other people, formed a company around what they did in their thesis project. And several of them are now the CEOs of their new companies launched right out of their PhDs. And there are investors who actually specialize in founder, like CEO company launches. And they're actually looking for literally young, inexperienced people who've never run anything before, much less an entire business, and giving them their first big break, right? So that is a thing that can happen. And it's not like anybody stops a Berkeley student from pursuing this. It's just there's so much less of it outside of Stanford that you just don't have a precedent in your world. You know, when I was in grad school, I never saw a PhD student file their thesis and then start a company as the CEO. There was no such thing as that in my world. So it would never have even occurred to me that that was like a viable career path. But now in my lab, a couple of people have done this, and I've noticed that the other students are watching them and saying, all right, if there's not rocket science, it's not rocket science. There's a path for something like this, and it's not easy, but it's precedented and people have done it. And just in the last 9 years, I've had, I think, 3 of my students and one of my postdocs. That's literally what they did right after their training. So Stanford is really cool. And I think you can learn a lot about entrepreneurship just by being in this ecosystem and having your eyes open to it. And I certainly am learning a lot from this ecosystem.
That's really great.
Yeah, that's incredible. Thank you for this encouragement. I guess we will all have something to think about tonight. Okay, we would like to open these questions to all of our audience in this room first, and then we will move on with the overflow room as well as the online. So who wants to go first? Go. Yeah.
Okay, hi. So that's really inspirational. Thank you so much. So I had a question. So what inspired you when you were like in your childhood? Like, were you like, did you always feel like you were born with like a passion and like deep interest in science, or did some like particular life like moment in your life like suddenly hit you like, wow, this is so interesting? And did you face any like obstacles? Like, did people like suppress you, like think that like you weren't supposed to do like science, since there's this stereotype that women aren't supposed to be in the STEM field? Or were people like the society around you really supportive of your career?
Okay, that's a lot. I can maybe start with the second part of your question about inspiration and obstacles and things like that. And so I was born in 1966, and that was a time when there weren't women participating in the sciences, at least not like at the level of these R1 universities, the sort of leading edge of research and so on. And I had 2 sisters, so my parents had 3 girls. And yes, at that time, there was an assumption, you know, the culture was such that women were assumed not to be capable as scientists, with a few rare historical exceptions, right? Marie Curie, you know, won the Nobel Prize in chemistry. But I think the typical girl, you know, who grew up like I did, would not have had messaging about she could be a scientist. In fact, you know, I would go so far as to say, like, when I was a kid, even like in school with your friends and your teachers and stuff, like the messaging was that, you know, like boys could be doctors, girls could be nurses, right? There was a lot of gender segregation in the workforce then. Most of our moms were stay-at-home moms. So, you know, I didn't have friends whose moms had careers, and my mom didn't have a career. They were home full-time taking care of kids. My mom didn't even get to go to college, and she wanted to, but her parents weren't supportive, and it was considered a waste of money. No girl would aspire to be president of the United States. That just wasn't even, you grew up thinking like, that's just not for girls. And so most women my age, you know, or girls born in the 1960s would not have contemplated a career in science unless they had a very unusual life circumstance, which I did. And the unusual circumstance for me is that my father was a physics professor at MIT. And he came from a very progressive family of Italian immigrants. And he grew up in poverty during the Depression. So he was born in 1931 or something like that. So this is right in the heart of the Great Depression. And he was the youngest of 5 children, and they just grew up in very deep poverty, food stamps, welfare, all of it. So he, had an experience in his life where, first of all, he was a scientist. Second of all, he grew up in a family that was very progressive. And third, he was very concerned about his children being able to have stable, independent livelihoods and not have to deal with the poverty that he grew up in. And he had girls, right? So he wanted his girls to be independent, self-sufficient, educated, people who could have a career and not be dependent on, for example, a marriage, which my mother was. She was dependent on him, because she didn't have her own means of income. And, they were married in the 1950s at a time when a woman couldn't have a credit card in her own name and she couldn't own property. Right. So my mother was entirely dependent on her husband. And that was pretty typical for women of her generation. So she didn't want us to be dependent on a husband like she was. She understood the insecurity of that. Like, what if something happened to my dad? What if he died? What if he became severely injured and couldn't work or disabled? What if they got divorced, right? Where would she be? She wouldn't be able to support herself. So we were raised with a lot of messaging around you can do anything, including science and preferably science, right? Because my dad, and that you should definitely go to college, have your own independent means of supporting yourself as an adult. So that upbringing insulated me from what was the cultural message around me in the rest of the world, which is that girls can do this and boys can do that, and girls can't do science or math or anything. So we were insulated from that. So I didn't actually know that the world thought girls couldn't be good at math and science until I went to college. We were so sheltered from that because my parents, and I have an older sister too. So I'm the middle. So my older sister was a math whiz, like a serious math genius, of the type where she was so advanced compared to the other kids in her classes that they were sending her to like older classes. And when she was in middle school, they had to drive her over to the high school for math and stuff like that. And when she was a kid, it was clear she was this math genius, but her teachers were not very nurturing of that. And she had a parent-teacher conference once where the teacher told my parents, she doesn't have a lot of friends. She's not that popular. And it's really because she's just doing too well in math. And so you might want to back her off a little bit on that, literally. Okay. And again, this is, ancient times, the 1970s. And, my dad came down on that professor, teacher, like a ton of bricks, and actually got him fired from the school, wreaked havoc on the principal and everything. They were kind of lead blockers for us, right? They were offensive linemen. Mm-hmm. And then, so my sister kind of ran the gauntlet with my parents clearing the garbage out in front of her so that she didn't get mistreated by her teachers. So when I came along 1 year later, you know how it is when you're in elementary school, you have the same teachers that your older brothers and sisters had. So when I showed up in those classrooms, those teachers were like, oh shit, there's another one. So they kind of tiptoed lightly around me, right? So my sister took a lot of the front, abuse, in that regard. So when I went to college, I had already have my brain wired with the assumption that if I wanted to major in science, that would be fine and I would do that, right? And so I didn't really encounter obstacles of the type you might imagine until like I was trying to become an organic chemist in college, right? Majoring in chemistry and looking for lab jobs and wanting to do research. That's when I learned that there was this culture where women were not welcome in the field. I just didn't even know that until I saw it with my own eyes. And then I was so angry and, I was like, oh my God, this is horrible. And then people would look at me and be like, where have you been? I mean, what rock did you just crawl out of that you didn't know this was a thing, But I think the reason that was fortunate for me was because I think when from childhood, you grow up with messaging that you're a second-class citizen, you can internalize that and it can give you a crisis of confidence, right? So I know a lot of people who, from a young age, sort of either directly or indirectly absorb the message of their inferiority. It's hard for them to stand up against these things, that they really just don't have the confidence. But since I had been sheltered by my parents from those kinds of things, I had the confidence that a lot of women my age didn't have when I was like 18, 19, 20, and so on. And by then it was the 1980s and things were starting to shift anyways. But, that's my story. So yes, I did encounter garbage. It didn't affect me as much as it might have had I not been raised with the confidence that I could be a scientist. But I didn't have an epiphany about science until college. Prior to that, I wanted to be a music major when I went to college. My parents were negative on that. So, again, back to the Great Depression, right? My parents were like, you can't support yourself as a musician, most likely. So please pick something practical and dabble on the side with music. So I did.
Thank you. Maybe it's perfect to continue this the question about college. I'm a graduate student from Harvard University. I'm visiting Stanford to do my wet lab research. And I saw that you were born in Boston. And then I was surprised that you have this experience, even just, you know, a couple of decades ago. I thought that's like 100 years ago. So my question is, what's your experience at Harvard and compare with Stanford?
Well, I was at Harvard as an undergraduate, right? So that was from like 1984, 1984 to 1988. Okay. And I don't have an experience with Harvard outside of that. And that was, unfortunately a long time ago I've aged a lot since then. So, the Harvard experience of me, in the mid 1980s was very different, I think, than you would have today. Certainly in chemistry, the demographics of the PhD program are completely different. Harvard had no women in their chemistry PhD program. They would admit maybe 10% of their class would be women. They would all quit by the end of their first or second year because it was very hostile. And now I think it's kind of 50-50 gender balance in the PhD program. The sort of greater experience of being in Boston and at Harvard of the 80s outside of the sort of chemistry bubble was politically very different from now, especially for a queer person like me. Because, 1986, I don't know, anyone here sort of follows constitutional law. Unfortunately, gay people often do follow constitutional law because Supreme Court decisions have given us rights or taken them away. But in 1986, rights were taken away. So there was the Bowers versus Hardwick decision in 1986, which was the Supreme Court decision that codified that a queer person, that homosexuality could be illegal if a state determined it to be so, right? So at that time, there were certain states in which even just saying, yeah, I'm gay, you were considered a criminal. And then in other states, you weren't, right? So you had to be careful where you traveled and things like that. And that's what that Supreme Court decision did, is sort of solidified that idea of criminality, of homosexuality. So that's like the world that I came out into, in the 1980s. It was right at the kind of like just coming up to the peak of the AIDS crisis. So a lot of my friends had AIDS and died. And it was a death sentence back then. And my first exposure to queer activism was AIDS activism. And so when I think of what was it like at Harvard at that time, I picture marching with ACT UP and Queer Nation down Mass Ave. We were trying to pressure the university to divest from South Africa. This was apartheid South Africa era, right? So, and a hostile chemistry department that was unfriendly to women and probably even more so to queers. But I was only sort of marginally out at the time. So that was my Boston experience, So now I think it would be pretty different there. I would hope, anyways. And just FYI, Bowers versus Hardwick got basically indirectly struck down in 2003 by Lawrence versus Texas, which was a different Supreme Court. This is why the Supreme Court is so important, because now in the year 2024, it is yet another different Supreme Court than it was in 2003 from Lawrence versus Texas. Lawrence could get overturned at some point, just as Roe v. Wade got overturned.
Hi, it's really a great pleasure to see you here in person, because I use a lot of orthogonal reaction during my PhD to modify the DNA origami of some antibody. Yeah. I spend a lot of time in the hood and just whole day to do the TLC. But nowadays, suddenly AI pop up and they say, oh, you can do in silicon simulation. Then you got the data just in one algorithm. You don't have to spend the whole month to do the synthesis. So I really wonder your attitude to the AI, how that will help, or they will get the true data, or are they superior? Yeah.
Oh, yeah, it's a great question. I know there's a lot of interest in developing, machine learning models to help make better predictions about the optimal conditions for a synthetic scheme or for a particular reaction. It's kind of early days, obviously, and I think like any machine learning application, it works best when you have a really well-curated data set that's large enough to train the model. So I think what people are working on now in the world of organic synthesis is figuring out, how to get the data set that you would use to train the model. Should it be from the primary literature? How do you scrub the literature? Using image analysis to find synthetic schemes. It's not that easy to scrub the chemistry literature because when people wrote and published their papers, they didn't format them in a way so that they would be easily mined by a machine learning algorithm, right? So I think just, acquiring the right kinds of data that, can be sort of formatted in the right way to train a model. That's kind of where the field is at right now. So it's early. But, once we have a PDB equivalent of organic synthesis, like a huge data set with reactions, conditions, yields, outcomes, could be really powerful, could save you a lot of time. It doesn't replace a chemist, right? But I think, yeah, we all avail ourselves of machine learning assistance when we can. It helps me pick things to watch on Netflix, right? I mean, it helps me. I use ChatGPT to search things when Google is a total failure. But it's all about having the data set that's powered adequately to train the model. One of the problems with organic synthesis is it's one of the few types of science where you don't actually show your raw data. People just take your word for it, right? And the biggest offender there is reaction yield, right? So there's 100 ways to reduce a ketone to an alcohol. Of those 100 different ways that you'll find from the literature going back 150 years, because this is old literature, a lot of it, of all of those different options for reducing the ketone to the alcohol, what's the best choice for your particular molecule where the ketone is in a particular context, right? Do you have to try all 100 to find the best? Hopefully not, right? Wouldn't it be great if a machine learning algorithm could look at the context of your ketone in your molecule and say, okay, based on what I've learned from 150 years of organic chemistry, you'll get the best yield if you choose this option out of those 100. The problem is, how do we know the yields in 150 years of chemistry literature are actually correct? Do students lie about their reaction yields? Yes, they do, right? I don't think there's a single paper you can get from the literature where you could literally reproduce the yield that somebody reported. They always inflate. They'll do it 5 times and pick the one time it worked the best. And it goes so far. There's certain chemistry professors, synthetic chemistry professors, who are notorious for telling a student, that's not good enough. That yield is too, I'm not signing your thesis until that yield is over 90%. Guess what? The next day, it's a miracle. The yield is over 90%. No one ever can prove this, right? Because how would you prove what the yield was? Are you literally going to videotape yourself weighing the final product and link it to the paper to prove that, yes, you got 3 grams and not 2, I mean, so that's the problem. How accurate and reliable is the literature that you're using to train your model? So my instinct is for organic synthesis to truly benefit from machine learning predictions of reaction schemes, you need, starting now, to acquire a really good data set on the 100 different oxidation or reduction methods and so on. So people are doing this using robotic, methods and so
on. Hi, Dr. Bertozzi. I'm here,
Where
right here.
Oh, okay.
I'm here. Hi, my name is Marwa Zafarullah. I'm a postdoc at the Stanford School of Medicine. And first, I would say thank you so much for making time and for being with us here today. It's a great honor. I'm just curious to know, like, during your scientific career journey, around what time, how, and when you realized that the science that you're working on has a novelty that it could lead to the Nobel Prize? Because many of us who are sitting in this room, we are being involved in multiple different projects. We are under training, but I can speak for myself that we might lead, lost in the way and have not the vision to realize what is the worth of science that we are being involved in, where it could lead us, let's say 10 years from today. So I really appreciate your response on that. Thank you.
Yeah, you're going to find it unsatisfying, I think, because I don't think a person ever fully appreciates the impact, the potential impact of the science they're doing. Once in a while, you know, somebody knows, okay, this is going to be really important, but I think that's rare, to be honest. It's certainly for me, there was no time in the development of bioorthogonal chemistry that either me or anyone around me would have said someday, you know, 20 years from now, the Nobel Committee will see how important this was. And somebody will nominate you, and then the nomination will go into a pool, and then this committee of Swedish chemists will look at it, and they'll agree that you should be the one. I mean, there's just no way that you can know that, right? You don't know what the opinions of this committee are ever. You don't know if anybody wants to nominate you ever. You don't know that, and you certainly don't know what the impact of the science will be. You know what you might know in the near term from, you know, when we developed those chemistries, we had a specific use case in mind. That's why we developed them. And we used them for the use case, and that's it. We were done, okay? And I think that alone would not have caught the eye of a Nobel committee. But what happened was other people saw, oh, look what she did with that. If that worked, maybe we could do this, you know? And all of a sudden it became adopted in a much more widespread way. You used it for DNA origami. That's not something that I ever planned on, you know? I mean, we weren't working on DNA origami. I think now anybody who does any sort of bond forming exercise in the context of a biologic, or they're going to use this chemistry, right? But it's not like that was the purpose that led us to develop it in the first place. So, and I'll go so far as to say that honestly, most of us don't know the impact of today's research that we're doing, and might never know it in our lifetime. It's a leap of faith, right? It's a leap of faith that what you're doing will have an impact. And you don't know what that will be. And how I can testify to this is that the work on which we built bioorthogonal chemistry was like those reactions were basically precedented by chemistry from 100 years earlier, mostly coming out of Germany, when Germany was the kind of epicenter of organic chemistry. And this was like basically before and a little bit after World War II. And so we dug into these old chemistries and then figured out how to adapt them so that we could use them in biological settings. But like, if we hadn't had the kind of foundational chemistries from, you know, people like Hermann Staudinger, who was a chemist from, you know, who first reported a reaction in 1919 that we then built upon for a bioorthogonal chemistry, or this other guy named Rolf Huisgen, who in the 1950s was working with azide alkyne cycloadditions, and that was the basis for today's click chemistries. And I can guarantee you that when Hermann Staudinger, you know, and Rolf Huisgen were writing their papers in the 1920s, 30s, 40s, 50s, at no point did they ever think, you know, 100 years from now, someone's going to do DNA origami and use our chemistry to build it, right? I mean, they could never have known that. But I think today you might argue that has been the most impactful consequence of the azide alkyne chemistries of the previous century, right? No one was really using them for much else. They're just an oddity from the old literature, right? So those guys couldn't have known what we would do. And likewise, we don't know what somebody, you know, your great-grandchildren will do, right? So it's just a leap of faith that you contribute knowledge to the world and just put it there and let it grow, and there'll be impact. And if you're really, really lucky, the impact comes in your lifetime and catches the attention of the Nobel Committee. But you can't predict that.
All right, thank you so much for this great answer. We're gonna have the overflow room ask a question, if we can connect with them. You can go ahead. Yeah, we should hear in the room.
Are they in this?
Yeah, maybe we don't hear you right now.
Can you hear us now?
Yes, perfect.
Yes,
Go ahead.
okay, good. Can you
Okay.
please repeat your question?
Yes. Hi, thank you so much. Thank you for coming here today, and thank you for the cool science that you do and your activism. One question I had for you, especially given that so much of this audience is women, which I am so happy to see so many women here today, is how can we deal with sexism today? I'm sure that, like, being a woman, you know, going through grad school and academia several decades past, it was probably a lot harder and trickier, and you've already kind of touched on that a little bit, but if you have any advice for those of us, dealing with those kinds of things today, I'd be very grateful.
Yeah, it's a great question. It's sexism today, it kind of has a different flavor to it because it's more covert. When I was younger, it was very overt. To the point where, there were, when I was an undergraduate, for example, there were a couple of professors, very famous chemistry professors in Harvard's chemistry department. They were organic chemists. And it was their stated policy that they did not take women into their labs. So if a woman grad student went to Harvard, she would have to, be informed that these two, whatever men, they just didn't take women. They were just not options for you. And it wasn't some hidden secret or anything like that. These guys would come right and say it. Sorry, it wasn't a good use of their resources. They thought, if they gave a spot to a woman, that was one less spot for a man who would do better, more interesting chemistry. They also thought she might be a distraction to what was otherwise an all-male lab. And sometimes even they were like, if I bring her in there and she gets offended by the men, then she's going to criticize me and then I'm going to get in trouble. And I just didn't want to touch it, right? But literally, they would just come right out and say these things. And I'm embarrassed to say now, but at the time, myself and the other women of my age, the students around there we just kind of accepted this as a fact of life. We're like, yeah, okay, that's just the way it is in life. And it sucks, but you just got to keep your head down and not all the doors are going to be open to you. And you have to find a door that's cracked open and that's the door you get to go through. And you just take what you can get, So already I'm very, I'm relieved and I'm optimistic because I know if that happened now, if one of your Stanford professors, when you went to meet with them to ask about a rotation or something, and that person said to you, thanks for your interest in my lab, but to be honest, you're female and I don't take women students in my lab. How long would that person remain employed at Stanford University, right? Hopefully not too long, So already you can tell the world has changed a lot, but that doesn't mean there's no sexism. Obviously, it just got driven underground because finally people started enforcing Title IX. Now, Title IX was on the books from 1972 or so on. So when I was in college in the 80s, Title IX was on the books. And does everyone know what Title IX is? Sort of, okay. Title IX was an addendum to the Civil Rights Act of 1969. And the addendum said that an organization, an educational organization, so a university, a college, and so on, or a high school, any sort of center of education, if they accept federal money, they cannot use those monies in a way that discriminates based on gender. Okay, that's basically what it says. And it's most familiar to people in the context of sports, right? So in other words, if Stanford University takes money from the federal government, which it does, it cannot then spend those monies in a disproportionate way where all the money goes to things to do with men and not to equally to women. And in sports is one of the few areas of the university where you do have gender separation in the organizations. There's men's sports and women's sports. So Title IX started to be enforced around sports. If you're going to spend all this money on football, then you have to somehow spend an equal amount on women's something, basketball, volleyball, whatever. But actually it applies to everything, not just sports. So for example, research groups at a university who train students, so it's an educational environment, we accept money from the federal government. We take NIH grant money, NSF grant money, right? Department of Defense grant money. So we're taking federal dollars. And if we only spend those dollars hiring male students and we refuse to hire female students, which was the case in the 1980s, we're committing a Title IX violation, but nobody ever enforced it. And that's changed. So now I think there's more understanding that, yeah, there's a law that it's illegal to discriminate in this way. So that gives you a little bit of cover from the law, but it doesn't give you cover from everyday covert attitudes. And those are, in a way, harder to fight because they're underground, they're subtle. You can't really prove it as easily, right? Just kind of you get a feeling something's wrong, but a feeling isn't an enforceable thing, right? So yeah, it's hard. I think probably the most important thing today to sort of limit and hopefully continue to diminish sexism is for women who do find themselves through whatever, survival bias, situation, they find themselves in a position of leadership, right? Very few women survive that gauntlet, but a few of them do. And if you happen to be one of the people who made it through that gauntlet and find yourself in a leadership position, then it's incumbent on you, and by that I now mean me, to be the voice that protects people from the covert sexism. So, if I'm in the room, let's say it's a faculty search committee, or if I'm on an admissions committee for PhD students, or what, if I'm in a room and I start to feel that, the tone is going in the wrong direction, as far as I'm concerned, like it's incumbent on me to say something, right? And if a colleague of mine, had a lapse of judgment and made a statement about, well, I don't like taking female postdocs because often they want to get pregnant in my lab. Who's heard that one? I have. That's when I come down on them like a ton of bricks. And I think now my reputation is such that people know that's going to happen. And so they don't say those things in front of me. Although, well, for the most part, you'd be surprised.
Okay, we had another question, right?
Hi. Hi, congratulations on all your accomplishments. You are truly inspiring, including the Nobel Prize for sure. With so many achievements, what helps you stay grounded and maintain focus on your work?
So am I grounded? That's great. Yeah. Well, the funny thing is, Nobel Prize is really an amazing experience. It's very exciting. You get a lot of attention. Okay. But in the real world, it doesn't really change your life that much, in the sense that my manuscripts get rejected at the same rate as they did before the Nobel Prize. Nothing's changed there. I just had an R01 renewal come up, and I submitted the renewal. It was it was my very first NIH grant. It's been running now since like 1999, very productive grant. It was the grant that had the Nobel Prize science in it and all these kinds of great things, all these wonderful things. It got reviewed. It got scored in the first percentile. So it was the top scored grant in the pool. And I'm like, yeah, I got to get my R01 renewed. And NIGMS calls me and says, you know what? We don't want to fund your grant. We feel that you're a senior investigator with others, probably access to resources elsewhere that we don't know about. And, so we're going to defund your lab from the NIH, right? And I'm like, well, that'll keep you humble, right? So, I have the same problems that I had, before the Nobel Prize. I'm still very privileged, so I'm not here complaining about this, but I'm just saying that on a daily basis, I still have to figure out how to make payroll of my lab. I still have to figure out, how do I help my students get jobs? How do we get our papers published so that they can go on the job market and compete? I have 3 kids, right? So every day I still have to, make sure that I do the things that have to happen, for kids, and I have to support them, and, they're teenagers now, and there's a lot of drama, around that. And so like every day there's still like life is in your face and you have to live it, One
more question.
Hi, thank you for your openness and enthusiasm. I'm wondering, for postdocs that want to move on to like independent faculty careers, I feel like we're probably trained for that versus the actual science. What do you advise people on that level, and especially people that have a young family?
So the question is, how can you get better training to be an academic PI, if that's your career interest?
Yes, correct.
Yeah, I would agree. I don't think we do a great job at that. It's better than it used to be. The fact that you even can ask this question is good, because when I came out of my postdoc, there really wasn't much in the sort of, there was no discussion even in the air about career advising, career mentorship, and preparation to be a manager of a lab. That no one even talked about it. It was just assumed you just figure it out on the fly. And most of us did, but there's a little bit of carnage along the way. So like when I started my lab as a new professor, I made a lot of mistakes, and I was unpleasant to work for. And 2 of my first 4 students quit at the end of their first year. I fired my first postdoc. And, by the time I had finished 2 years as an assistant professor, I had fired or had quit more people than I had in my lab, at that point. So I was not a successful mentor. And it took me, I had to sort of have like these moments where I was like, okay, what am I doing here? And why am I doing this? And why isn't it working? And so, I did figure it out, but like, it could have been easier and it could have been more pleasant for people along the way. So I think the hardest thing for me starting out was the people part of it. Because I knew how to write papers. I'd written enough papers in grad school to know how to write a paper. I kind of knew how to write grants because I had done, at least parts of grant applications, and stuff. So that wasn't so much a hard part. It was really how to train, motivate, deal with inexperienced people, young, inexperienced people who, half of whom aren't even sure why they went to grad school. Right? I mean, a lot of people go to graduate school because it's like the next thing and the barrier is low. You don't have to take out loans to go there, which you would then have to worry about your salary to pay back, which is like med school. So it's just this open-ended thing and people just do it and not all of them even know why they're there. Right? So I just didn't have any clue how to deal with people like that, even though I was one of them. Not that many years earlier, I was one of those grad students where 2 years into the PhD program, I was like, why am I here? Why didn't I just go to med school? I bought the MCAT tutorial book. I was I was planning my escape from grad school for 2 or 3 years even. I don't know. I mean, I was hardly a model grad student, but somehow when I started my own lab, I forgot all of that, and I was like, how do you deal with these people? Why don't they read my mind? I mean, right. So, that's where I think I could have used the most mentorship. The other thing is I didn't fully appreciate when I started my job what all the opportunities would be as an academic. I didn't have my head around like how much you can do from a home base as an academic. And now I feel like I probably could have made better use of the flexibility and the opportunities than I did even, So I don't know what to do. Does Stanford have like a mentorship training activity that you can sign up for? Stuff, are things like that for postdocs where you can avail yourselves? And okay. Is there a place where a person can figure that out easily? Is there like a website where like, here's all the postdoc mentorship things? Okay. Oh, you use ChatGPT to figure it out. Okay, so get on ChatGPT and ask, how do I get trained to be a professor at Stanford University? So I think maybe that's the way to do it.
Hi.
Say it again. You can get a mentoring certificate even. Ah, that's cool. Put that on your refrigerator next to your kindergarten report card. Yeah.
It's wonderful to hear you, Dr. Bertozzi. So now that you've received the Nobel Prize, you're kind of in the epitome of success in science. And you said your parents didn't let you do music. So what if your kids wanted to do music? Would you let them?
Yeah. I think I was probably too anxious about pleasing my parents. I was raised that way. I didn't have a rebellious bone in my body, right? So when my parents were like, if you declare a music major, you can take out more loans for your tuition as far as we're concerned, right? It was a bit like that. And even when I was in college, I actually did play in a band for money. Like that was my, weekend income. And one of my bandmates was like a really great musician, although he was not a music major either, but he, was a brilliant guitar player and he did go on to have a career in music. And when he graduated from college, it was 2 years ahead of me. So I was just like finishing my sophomore year when he graduated. He actually, we had this band and he tried to convince the rest of us in the band to leave college and go with him and go to California, and everything, become a musician. And I was like, oh my God, my parents would kill me if I dropped out of college to go become like a rock musician, in Los Angeles or something. And I mean, it was just like a non-starter for me to even think about it. In hindsight, again, like I think I wish I had been more, a little bit more rebellious or a little bit more autonomous in my decision making. And so, yeah, so if my kids, like one of mine actually right now, he's only 13 because they're a bit young, but still, if you asked him right now, what do you want to do? He'd say he wants to be a rock drummer. He plays the drums and also some piano, and that's like his thing. And I think I would say, yeah, all right, what can we do to help you find that path? And I think it's a luxury for me to say that because I did not grow up in poverty. I grew up comfortably middle class. I've never known what it's like to not worry how you're going to pay your rent at the end of the month. And a lot of musicians worry about that, right? But I don't know that feeling. And since, again, my parents grew up very poor in the Depression, right? So they grew up in a world where, if you can, you want a career that is stable and safe. That was, to them, it was all about stability and safety. You can understand that from their upbringing. But since I, had the luxury of not having to worry about stuff like that, it's easy for me to tell my 13-year-old, yeah, be a rock star, man. You might end up working at Starbucks forever, but again, there's a certain privilege that comes with encouraging your kids to do something, that's insecure.
Nice. Maybe last question.
Hi, thank you so much for being here. I guess my question is, what is something that started or piqued your interest in chemistry, like during your college years?
How did I get interested in chemistry?
Yeah.
That's easy. Yeah. So it was when I took sophomore organic chemistry. I gave no thought to chemistry before that. I didn't like it even. I would say it was like not, I did it because I had to, because it was a requirement and I was a pre-med at the time. But I did not like high school chemistry. It made no impression on me whatsoever. I hated freshman chemistry. That was like the worst class I ever had to this day. It was freshman chemistry. So I had no affinity for chemistry, but then organic chemistry was actually very different from the chemistries I had experienced before that. And that's where I was like, this is it. This is my thing, So I was already in college at that time.
Wonderful. Maybe we can have our last question from Francesca now.
Thank you so much for the wonderful talk. And to our speakers, we always ask one last question. And in your case, because we are very fascinated by the way in which you describe molecules. So you say that the molecules have personalities, right? This is a beautiful concept. And we were wondering, after this experience here with us at the iWISH, if you'd like to explain this, what's the molecule that you'd associate with us?
With you? What's
yes.
this?
What would be the personality of the molecule?
What's your personality? Well, what are you? Let's start with that. You are forward-looking. You are seeking community, strength in community, right? Togetherness. What else? You are, I think, probably a lot of diversity, right? So, forward-looking, togetherness, diversity. What are you? I would say you're definitely a macromolecule, right? And I would say you're a polysaccharide. Because you're sweet and optimistic and mysterious in certain ways. You work as a collective. Yeah.
Thank you so much.
Okay.
We have one more. So we would like to maybe close the event with the online folks, and then we can have a few minutes with you afterwards, if it's okay. Yes, we can share the screen. So we would like to this one. We have, yeah. So we would like to just remind you guys, we have our next event, in November, the 21st of November with Johnny Ruther, which is the director of NCATS. So please stay tuned, go online and register yourself, because we already have open registration. And with this, we would like to thank our main supporter, which is the Stanford Cardiovascular Institute, and Dr. Joseph Wu, who really is our main fan and supports all our events and the iWISH since the beginning. And also the Alumni Association for their help on these. And our sponsors, very kind sponsors, we have Select Chem and BioRender. We have Sunny here in the room. So if you guys would like to have and ask some questions about this, you can. And Enrica joining online. And with this, we really would like to thank you all. It has been amazing to have you in our talks, and we look forward to have you in the next one. Thank you.